Hello everyone. So this is the fourth and final video about dealing with vectors. There will be another video about other data types in R that sort of rounds out the R thinking about data module, but I think it's helpful to think about these sort of four vector-oriented videos as sort of fitting together. So this final video, what we're talking about is missing data. So this is simply a case, right? And this happens all the time in the real world where you have some set of measures, but one of them was not observed. Someone messed up, it wasn't recorded, whatever. So R, the most common way that missing data is recorded, and there's a variety of ways people handle this. Sometimes you'll see weird code books where someone's like, we recorded all missing values as minus 999 or something like that. That can get kind of weird. In R, it's simply NA values. And you can see that NA is sort of like a special type of thing R recognizes as being, like a unique thing of significance. It's not simply those letters. It actually means something. Is that when you type a capital N, capital A, R actually, it prints out, in this case, it becomes like a blue value in my console. It might become something else in yours. Sometimes you'll see folks, you'll see in certain cases an N, a lowercase a, and then an N. It's ultimately representing the same kind of thing. We're going to stick with NA here, and I'm not going to get into the weeds of why both of those exist and what the different role is. Okay, so let's create a vector, and in this case, it's going to be a vector of what we'll call heights, and it's going to have 4 observed numbers and 1 NA value. So 2, 4, 4, NA, and 6. So the first thing we might want to do is let's just use the mean function, which I think we've used before. We'll call mean on the vector heights, and what that's supposed to do is calculate the mean value from all the numbers in that vector. But if we do it, R spits out an NA value. What's happening there? Essentially, R is saying, hey, we tried to take the average of these 4 numbers and this NA value, and we have no idea what that average is. What is the average of an NA value? It doesn't know. That's going to happen for basically all like max, median, min, any of those sort of like basic calculator functions. If you call them max, it's also going to spit out an NA. I highlight that for max and min because you might think that it still like grabs the highest value or the lowest value observes, and it won't. It'll break. And so anything with an NA value, if you call mean or max or one of the more complicated versions like row means, call means, things like that, it's going to spit out an NA. R is aware of that. It has a toggle to address it. Let's check it out. So let's say mean heights. And if you click tab, you're going to see, or if you look at the help file, you will be able to read that R has a couple different adjustments you can make to these basic calculations. The one we're focused on here is this one, na.rm. So that is an option in the function that you can toggle on and off. By default, it's false, which means R leaves the NA in, tries to calculate it, and breaks. But if you set na.rm equals true, in this case, I'll just use that capital T. What's going to happen is R is going to kick out all the NAs and then take the mean of the rest of the values. In this case, that value is 4. It just takes the mean of 2, 4, 4, and 6. We can do the same thing with a max function. Remove NA, now it tells us 6. We can do min, heights, NA to RM equals true, and it'll spit out 2. Okay, awesome. A couple other things you might want to do. Sometimes you want to like select out or in contrast remove NA values, or you want to be able to know how many values are NA or which values are NA values or not. So the base function your go-to here is just a function in R called is.na. And what is.na does is it looks at the vector you feed in and it simply prints out true when a value is NA and it prints out false when a value is not NA. So in this case, we feed the heights vector in. Recall that heights is this 244 NA6, and is NA returns false, 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 true, and false. So the way we flip that around, let's say you actually wanted to pull out the non-NA values, right? Because if you recall, if you're using Boolean indexing, the trues get returned and the falses get tossed. And so if you want to keep the good values, you need to invert this function. So there's no function like is not NA. Instead, what you do is you put an exclamation point in front of it. If you recall sort of like doing algebra, right, that exclamation point is saying like not. And so in this case, what R is saying is it's saying is NA, and then it flips that like not NA. And so it ends up producing trues where there would be falses and falses where there would be trues. So it's like taking that true false value and totally inverting it. And so if we say not is NA heights, you get true, 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 false, and true. You can see that that exclamation point is also a special character in R. In my screen, it becomes that light blue color. It might be something else on your screen. But again, R recognizes that when you put not in front of something like that, in front of a true or false value, it flips it around. You can put it in front of other things as well. You get weird values. You can play around with why that is the case. In fact, that's sort of a good challenge. Like if you put exclamation point 5, why does that return false? In any case, so now we can use that strategy to subset out things from the heights vector and get rid of missing values. So in this case, we're going to say not is NA heights, and we're going to put that inside the brackets. And so now what's going to happen if we run that is it's going to kick out the NA and now leave us with a 4-item subset of just the non-NA values. Sometimes you'll see someone use a function instead of that. They'll use like complete cases. Complete cases is a function that doesn't have a lot of use on a vector because each of those it's either NA or not. But complete cases factors in is actually you can then apply it to like a data frame or a matrix, and it looks across the row and says, are there any NA values in this row or not? Return or do not return. We'll play around with that. It'll become more useful when we're talking about subsetting matrices and data frames. Okay, so that is the sort of conclusion of vector math, vector operations, vector subsetting. Let us know if you have any questions.